Okay, so for today we'll be doing mass, weight and density. So these are three different things in which mass is just the amount of matter that's found in your body. Amount of matter. Whereas weight is usually the amount of matter plus the influence of gravity. So for example, if the gravitational field strength is high, on Earth it's actually 10. So if it's 10, then what you have to do, you have to multiply to the mass. Whereas let's say we go to another area, like let's say the moon, which has more or less a gravitational field strength of 6, then the weight will be different. However, the mass between both locations on Earth and the moon must be the same. Last but not least, we will be looking into density, where density is basically in the consideration of how well the amount of matter is being packed in a volume, in a fixed volume or in certain volume per se. And how will it influence? It will influence whether the item will actually float or sink in another medium per se, let's say water or an oil. Okay, so what is mass? Mass is a measure of the amount of substance in an object, and that the SI unit for mass is in kilograms. Okay, do take note that the conversion from 1 kilogram, right, to grams, right, is actually 1000. So 1000 grams equals to 1 kilogram. And how do we go about measuring mass? We use two instruments called the beam balance or the electronic balance. Now this is very different from the weighing balance later on, because the other weighing machines tend to measure the weight rather than the mass. So for mass, in exam we tend to try to identify the word balance as one of the key indicator to show that it is actually to measure mass. Okay, and mass of an object is constant regardless of where regardless of where you are, and it is also not affected by the gravitational field strength of the planet. Okay, so next we look into inertia. So inertia is basically the tendency for an object to resist a change in its motion or a state of rest. What this means is, for example, when you are already sitting down not doing anything, how much amount of resistance you actually face, right, to actually try to move up or to change in location or movement. So that's the thing, even for an object it's the amount of tendency of it to resist this change. Okay, so an object at rest will always remain at rest because the object will want to resist any change in a stationary state. For example, let's say you have a coin, in TV you usually watch like wine bottle or dishes on the table, and people pull the cloth underneath it. Then what will happen is this item will always stay stationary there, and this will actually help to show that there is actually very high inertia by the coin, in which it tries to resist a change in the motion. Okay, and another example is like a ball moving with a certain speed will keep on moving at the same speed on a frictionless surface. This is because the ball is resisting any change to its constant motion. So this is another example. So it's like it will just continue to move in the same direction consistently. Okay, then that's inertia. Next, when we look at mass and inertia, when we take two combined together, right, we will see that the amount of inertia of an object really depends on the mass. How does it matter? Having greater mass of an object, you will have actually greater inertia, meaning you will need actually a lot of energy to result in that change. And if you need more energy to result in a change, then it is able to exert a greater resistance to that change. So the heavier you are, the harder it is for you to move. So imagine it this way, when there's an elephant chasing after you, the elephant is bigger in size and everything, and you suddenly change direction suddenly, the elephant will be very difficult to change the direction because of its mass, and therefore it will actually topple down forward rather than moving sideways. So what we can see is more effort is needed if we want to actually change the state of the motion or rest. So for example, when we look at these two items, a 2 kg block and a 10 kg block, it takes more effort to actually move the 10 kg block, but rather because of it having sufficient amount of mass, a lot larger than the 2 kg block, you will need more energy to actually move the 10 kg block, and therefore this 10 kg block will have a greater resistance to change, and as a result it has a higher inertia. So some examples of inertia in our daily lives is like when you shake the bottle of a ketchup or chili to move its content out of the bottle. So that is one example where the inertia of the chili inside the bottle just doesn't move that much. So we tend to actually try to shake it vigorously or forcefully. You can use using a downward motion and suddenly stop of the hammer to tighten the hammer head. So another one is like when you while starting pushing on the cart to move, the object on top may actually fall off. This is the same idea when you have the cart here and you have some items on top of it. If the items are actually very I would say big and bulky, okay, when you apply a lot of force to push the cart very fast, this object here has a high resistance to move, to change, therefore it may drop down due to inertia. And our body push to the front of a bus when the bus comes to a sudden stop. So that's another example. Okay, so these are some questions. You may like to pause the video to try it out, but these are the common one they need to know, like definition of mass and inertia and how are they relatable. You also need to be able to use the concept of inertia to explain some scenarios. Most of it requires you to state what is the inertia and how is it being influenced by mass, therefore ending it off with the resistance to change due to the force. Okay. Moving on, we talk about gravitational field, where a gravitational field is this region in which a mass experiences the gravitational force of an attraction. And this definition of gravitational field strength is the gravitational force per unit mass. So we tend to use gravitational field under the units of Newton per kg, which actually say for every 1 kg of movement, what's the amount of force required. Okay, and so what we can see is on Earth, right, it tends to be in this manner, 10 Newton per kg, or we can actually say it's the equivalent of 10 meter per second square, which is acceleration. Okay, and how is it so? This comes in from the same formula of your force, where force equals to mass times acceleration. So weight is actually an example of a force, and the acceleration is just like your gravitational field strength. So what can happen is, like for example, a free falling object would have an acceleration of 10 meter per second square. What this means is after it keeps falling, the fastest rate of acceleration will still be 10. You cannot hit 11 or what unless you actually add in other kinds of force to push it forward or push it downwards. Okay, so every 1 kg of mass near the Earth's surface would experience this amount of 10 Newton force. So in exam, like not say in exam lah, but when pilots they actually try to pull up straight and then they tend to face and shoot upwards to outer space, then you will see that they will experience a lot of G's lah. G's means the G force. What will happen is they will feel a lot of weight. Their weight will suddenly feel very heavy because they are going against gravity. So when that were to happen, right, there are two scenarios that can happen. Either you pass out due to that sudden change in force, or you will actually you'll be in great pain. But this is only momentary until you hit outer space. Okay. Weight really depends on the gravitational field strength acting on it, and the SI unit for weight is in Newton. So this gravitational field strength really varies in different planets or location, so the weight of an object will generally change. So we can see that the gravitational field strength for Moon and Earth is actually very different. Just now I say 6, so I'm sorry for that mistake, but generally for the Moon's surface is 1.6. And what we can see is, like, if let's say on Earth you jump, you tend to drop down very fast, but on Moon's gravitational field strength, you tend to jump, right? You are able to exert a greater amount of force than the gravitational field strength, so you can think like you're floating. Okay? But because of the Moon still have gravitational field strength pulling you back down to it, you will not be able to constantly fly. You will still drop back down. So the weight of an object can be measured by using actually a spring balance. And a spring balance is something like anything that has a spring. So there is two kinds, a downward and upward spring balance. So what happens is when you have a downward spring balance, right, they tend to, you hang the thing and this tends to extend. And the tension of it being extended will actually represent a direct proportional to the amount of force required or the weight required. However, for the ones that is being squeezed, the one that's being compressed, right, there's the other one that is just a normal weighing balance. And what happens is this is also being influenced by gravity. You could see that these two really is being influenced by how much gravity plays a role. However, when we look at the beam balance, right, what happens is you tend to actually put weights at the side to the object that you are trying to measure, so that you could actually measure it based on the amount of mass. And gravity tends to cancel out each other for a beam balance. This is only for measuring your mass, not your weight. If you want to measure your weight, it's W equals to mg, where weight equals to mass times gravity, in which it's a direct same transformation from force equals to mass times acceleration formula. Okay. You may want to try out some of these questions so that you get an idea of how to go about doing the calculations. Okay. But this is the key thing that you have to remember of the difference between the mass and weight. This is actually a very common question that they tend to ask. So for mass, they tend to ask, number one, what the measurements of the the amount of matter is, and that it is constant everywhere. Whereas for SI unit for mass, it is actually in kilogram. What do they mean by constant everywhere? It means regardless of where you are. Let's say, are you on the moon, are you on Earth, or what part of Earth, even with the change in gravitational field strength, you will still have the same mass. Okay, and this one, the SI unit is in kg. For weight, is actually, because it's actually a force, a type of force, the SI unit is in Newton, and it varies and very being dependable by the gravitational field strength. So if you are in an area that has a higher gravitational field strength, your weight will be higher. If you are in an environment where the gravitational field strength is low, then your weight will be lower. So really, weight is a measurement of how much gravitational force acts on the body itself. Okay. Finally, we move into density. So density is this measurement which actually considers your mass per unit volume, where it measures the amount of mass that can be packed in one volume, maybe in cm cube or in meter cube. So in this case, we could see that the SI unit for density is actually kg per meter cube, and this indicates how packed the matter is in a given volume. So having a higher density would show that there's more particles being squeezed into a very limited amount of volume, as compared to having a lower density where your particles are highly spread away. The mass is actually lower, therefore it can actually more or less float up on what's not. So every substance would have a fixed density. What does this mean? It means that, let's say, a piece of wood, no matter how much you cut it, big or small, it will still retain the same density. Why? Because like you cut the wood, you throw it in the ocean, the sea, it tends to float. You take the same wood, you throw it into, let's say, a swimming pool, it still has the same density. So that's what they meant by a fixed density value, in which by adjusting the different size of it, you will not suddenly change the density of that material itself. Okay. A common question in exam that you will need to know is, they can give you a drawing like this, like ABC, and you are required to actually indicate which one will have a higher density or lower density. This one in exam, they can give you a data. So what you should take note that densities that tend to actually float up have lower density as compared to the medium of the solution or the liquid. Okay, don't say that it has low density. Instead, this one is about a comparison between the solution you use and the density of the object that you actually use. So in this case, A has the lowest density as compared to the other two because it's able to float. And C would have the highest density in A and B because it tends to sink down, and B is definitely the density of the liquid. How to then we calculate density? We use the formula mass over volume, where density equals mass over volume. In your explanation with regards to density, you have to always take reference to what is the mass and volume. So if let's say you are given two comparison between A and B, they are of the same maybe volume, then you could say both A and B have the fixed volume. However, since A actually floats up, so A would have a lesser mass as compared to B. This will then result A to have a lower density than B. Therefore, it gets to float up. Okay, you can also take a look at some of this question and try. Pause the video, try, see how to do it. Okay, for work example 2, same thing, and work example 3. Now, work example 3 is another illustration of how are we able to get density, because for mass and weight there are actually instruments to help us to measure, but for density not so much. So what happens for density, right? First of all, you need to measure the mass, which you can from the beam balance and also from the weighing balance. However, when you want to measure the volume and volume of any irregular object, you can use this method, where you first take the initial reading of volume of maybe water or solution, put it into a measuring cylinder, get the initial reading. Then after that, you put in the irregular object, you find the final reading, you subtract. That will be the volume of the irregular object. And question 4 is just more calculation. Same thing, if they ever ask you to find density, let's say they take two different objects, they melt it and then combine it, and then they will have a new density. You cannot take the density of the two objects, add it together and divide by 2. That is not how you measure the density. Rather, you must total the mass of both objects and also total the volume of both objects, and you divide both of them to find the density. Okay. This is another revision question which you can actually try out. Do buy the book, then you can also practice more questions. Okay, so that's all you need to know for mass, weight and density. You need to know the difference between mass and weight. You need to know the units as well as how to go about measuring mass and weight. You will need to be able to explain the concept of inertia, and finally you need to be able to apply your knowledge learned for doing calculation for density as well as explaining the scenarios for objects of different density. Now that's all.